7.1. Unit 7 is all about financial applications of functions that we've been working with throughout the semester. And they come into play a lot when you're talking about needing a loan for something, or maybe investing some money in something, or maybe withdrawing money when you're in your time of retirement. And a lot of it connects back to, again, the functions that we've been working with. The first thing that we're going to tackle, which is what we do in 7.1, is simple interest, which is really just a very foundational understanding of something that happens in finances, and it's directly related to arithmetic sequences and linear growth. It's not super practical for real world applications, but it's a building block. Later on, we get into compound interest, which deals with exponential functions, and you'll see a lot of similarities in the formulas that we use, and you'll be able to grab hold of it based on the things that you've learned already in this course. So here we go, 7.1, simple interest. Whether you are borrowing or investing, there's almost always a fee that the borrower charges, and this is called interest. Interest is something that can be paid. In the case of if you're borrowing money, you're going to pay interest, or interest can be earned. So if you're investing money and your investment is doing well, you're going to earn money, on that investment. Okay, so here we go, a couple of definitions. We're going to start with the definition simple interest. We'll go simple interest. This is interest that is calculated, only on the original principal. Of an investment. Let's not write that. Interest that is calculated only on the original principal using the formula I equals PRT. And I'm just going to use different colors and some arrows here. Try to keep it tight, small, because we do have more notes to go. But I is going to be the interest. And remember, that could be paid or it could be earned. P is the principal, which we'll write the definition for in a minute. R represents the annual rate of interest, and T is time in years. So there we have the basic formula for simple interest and all of the pieces of it, okay? So we have interest is equal to the principal, the amount that you start with, times the annual rate of interest. So just a quick example, you don't need to do this, but if you were getting interest at a rate of 5%, you would multiply your principal by 0.05. And then time in years, if you did that for multiple years, you just stick the number of years there and you're good to go, okay? So principal, let's get into our definitions from within this formula. Principal is the amount of money initially invested or borrowed. Amount of money that is initially invested or borrowed. So when we're talking about simple interest, let's say you invest $500, you gain interest on it, you're only gaining interest on that principal. That $500 remains the number that you use as the principal. And we have our annual rate of interest. Annual rate of interest is the rate at which interest is charged, comma, annually. That's pretty straightforward. And when we use it in our formula, we expressed as a decimal. Familiar with that concept. And another word that we need, which is not from this formula, but amount. Whenever you hear the word amount and you're talking about interest or investment or borrowing or anything like that, this is the value of the investment or loan at the end of a certain time period. The value of an investment or loan at the end of a certain time period. And A equals P plus I. Okay, so if you have invested money, you've invested $100 and you did it for 1 year and you got a return on that of 5%, okay, then the amount that you have is the original $100, your principal, plus the interest that you earned on that principal, which would be $5 in this case. So the amount would be $105, okay? It's the principal plus the interest that you earn on it. Where does this interest come from? It comes from this formula right here, okay? And again, while simple interest is rarely used in banking today, it's still important to understand the fundamentals before we move on to the more advanced concept of compounding interest. Okay, in our investigation, we have a situation where Alex receives $1,000 gift for his grade 8 graduation. He decides to invest the money at 5% per year, simple interest. Fill in the table below. So what do we know? Well, we know the principal, the initial amount, is $1,000. And we know the rate is 5%, but we don't write 5%. We express it as a decimal, 0.05. Okay, and we're asked to calculate the amount. So all I need to do each time for each year, this is t, right? T equals 1, t equals 2, t equals 3, t equals 4. Really what we're going to be doing is plugging it all in, if we wanted to this amount formula, which could be the principal that we're starting with, plus I, but instead of I, I'm just going to put in PRT, because those are all the variables that we know already, okay? So let's put a 1,000 in there for a principal. So we have that original 1,000, and we're going to add 1,000 times 0.05 times t, all right? So let's say t equals 1. Then we have, that's kind of just anything times by itself is itself. So 5% of 1,000 is $50, plus the original principal, we're going to have 1,050, okay? Go ahead down the list, plug in 2 for t, get the amount. Plug in 3 for t, get the amount. Plug in 4 for t, get the amount, so on. Pause, finish that, and check back for the next step. All right, hopefully your amount column looks like this. Our next step is to calculate the first differences, which means we're going to be taking 1,100 minus 1050, and we're going to get a difference of $50 there. If we do it again for these guys, we get a difference of $50. In the next row, we get a difference of $50. In the next row, we get a difference of $50. Okay, so the first differences are constant at an amount of $50. So what type of relationship do we have? That's a question at the bottom underneath your chart. What type of relationship is this? Hopefully you've identified this as a linear relationship because the first differences are constant. Determine the slope of this relationship and the vertical intercept. All right, now we're thinking back to our linear functions. The slope of anything can also be called the rate of change. It's also determined by the first difference. Every year, the value of this investment goes up $50. So 50, rise of 50 over 1 year. So we have a slope, that's m, of 50. Well, the y-intercept, if you remember back to direct and indirect variation, that's a grade 9 term, that's the amount that you started with. So if we were going to graph this, we'd start at a value of 1,000. So that's our y-intercept. Variation, partial, direct variation, or above that, write an equation to relate the amount to the time n, where n is the number of years. We've already kind of done that right there. We've got a equals p plus p times r, and this time they want us to use n to represent the number of years. We could simplify this. We could actually factor out the p. And we'd be left with that statement. And if we wanted to actually generate the equation, we simply sub in what we know. So we have a principal of $1,000 multiplied by 1 plus r, which is 0.05 times n. You can simplify this. It's going to be 1,000 plus 50n. And there's a formula for the amount. Of course, that's the same thing. I wrote it up here again as well. If we just summarize what we have here directly from this formula, which is same as right there. Okay, so we got the same thing in both ways. Here we're using t. Here we have n for the number of years. And we carry on. It is partial variation. Remember, direct variation would mean that the amount varies directly with respect to n. That would mean if n is 0, a has to be 0. It goes through the origin. But in this case, it doesn't. We have an initial value of $1,000. So it varies partially with respect to the number of years because it does not go through the origin. Consider the values in the amount column. What type of sequence do they form? So here we have an arithmetic sequence. I'm going to jump over to the next column here. We have arithmetic sequence. Why is that relevant? Well, that means we can use the formula for the general term to create a formula for this sequence. So we're going to first identify A, the initial term, and D, the common difference. Now be careful, the initial term is not the principal. The initial term is what we have in this amount column. The first term is 1,050. 1,050 with a common difference of 50. But now if we take our term for the general, our equation for the general term in an arithmetic sequence, which is t sub n equals a plus n minus 1 times d, and we sub in what we have here from our sequence, n minus 1 times 50, and we work down, we simplify this by distributing, plus 50n minus 50 equals 1,000 plus 50n. We end up with the exact same formula. Instead of using A to represent the amount in the column, we have the exact term, the value of the term that we're looking for, so which is the amount, in the account. Let's say after 5 years, we would just plug in n here and we'd get $12.50, okay? So there is a strong relationship here between simple interest and arithmetic sequences, all right? Let's apply this connection to some examples. In example 1, we are asked to calculate simple interest. So I'm just going to, right at the top, put my formula for simple interest, which hopefully by the end of this example I have memorized. It's the principal, the amount that I put into the account, times the rate that I earn interest at, times the number of years that I leave this money in the account. And we're always going to express R, the rate, as a decimal, and the time in years. All right, so in A, you have how much interest is earned if $1,200 is invested at 5% simple interest for 3 years. Well, let's write down what we know. We've got I equals PRT. We have a principal of $1,200. We have a rate of 5% as a decimal, and we are going to leave that invested for 3 years. All of the information is there. Click away in your calculator. You end up with $180. Now remember, this is just the interest earned. If you pulled that money out now, you'd get your original $1,200 plus the $180. Okay, but we're not asked to do that in this question. So the amount earned, because you're earning interest on this investment, so in this case the amount earned is not the total amount, it's simply the interest, is $180. B, I equals PRT. How much interest is paid if $400 is borrowed at 8% per annum? So there you have another word for annually. You might see per year or per annum or yearly or annually. They're all commonly used words. They all just mean per year, okay? So we are borrowing $400. And are we going to be paying or getting interest? We're going to be paying interest in this case because we're borrowing. We're borrowing at 8%, so 0.08. And we're going to do it for 7 months. Now remember, T is always measured in years. Well, now how do I represent 7 months in terms of years? I simply say there are 12 months in a year, and I'm going to borrow this for 7 of them. So for 7/12 of the year, I'm going to be accumulating interest that I need to pay back on this thing. And we always round money to the nearest cent. You click this in your calculator, and you end up with approximately $18.67. In this case, interest paid is $18.67. C, we have our formula, I equals PRT. Go ahead and try this one on your own. How much interest is earned if $900 is invested at 4.25 annual simple interest for 90 days? How are you going to reflect 90 days in terms of years? Go ahead and try it and check back here to see how you've done. All right, we have a principal of 900. We have a rate of 0.0425. And we're going to be doing that for 90 days. That's 90 out of 365 days in a year. Click away on your calculator. You'll end up with 9.43. Interest earned is $9.43. In example 2, we're going to develop a linear model for a simple interest scenario. The scenario is this: Robert deposits $500. So his deposit is $500 into a guaranteed investment certificate. Deposit $500 into GIC, Guaranteed Investment Certificate, that earns 6% per year. That's pretty sweet. You don't see those anymore. Simple interest. Okay, they always write simple interest for you. It doesn't really matter at this point because that's all you're familiar with. But later on, as you get introduced to compound interest, you'll need to be able to differentiate between the two. So here we are working with simple interest, and we're going to develop a linear model to relate the amount to time and identify the fixed part and the variable part, then graph it. All right, well, this is partial variation. Partial variation, the amount that is, because we have an original amount and then we're going to gain interest on it. So it will vary partially with respect to the interest earned. We're asked to get a formula for the amount. We have amount equals P plus I, okay? But we also have that I equals PRT. So here we are, we're going to stick these two together. We're going to get P plus PRT, okay? So let's go ahead and put those pieces in, put in the information that we have. We know the amount. We have a principal of $500. So we put that in wherever we see P. We've got a rate of 0.06, and T stays because it will vary with respect to T. So 500 plus 6% of 500 is 30 T. All right, there we have it. The amount given is amount equals 500 plus 30 T. And if we were going to graph this, which is what we need to do, we've got time and amount as our axes. Okay, we'll graph it over, say, the first 1, 2, 3, 4, 5 years. 1, 2, 3, 4, 5. Amount, well, we're starting at 500 and then we're going to go up 30 bucks every year. So maybe we'll just go 500, 1,000, 1,500. We're obviously not going to get this high with the numbers that I've used here, only up to 6 years. Could have done more years, but that's okay. Starting at 500 and we're going 30 up for every year that we go over. So after 5 years, we're going to be up $150. This graph is pretty useless as an example, but let's just say it's doing that. And this is our formula for A equals 500 plus 30T. If I wanted to do a better job at this, I'd probably give myself a broken vertical axis. I give myself more time, maybe 20 years. Doesn't say how long he's going to be doing it, so let's say 20 years, 10, and we'll start at 500. But then I don't have to go up by 500s. I can go 600, 700, 800, 900, 1,000. And now, since I know it going up 30T, then after 10 years, I should have gone up $300. So from 500 to 800 after 10 years. And then your graph will look like that. That's much more helpful. This doesn't tell us much. If you're looking at that graph, pretty hard to discern what's going on. So this is amount equals 500 initial value plus 30T, $30 per year. All right, B, we're asked to determine how long it will take for this investment to double. Well, if we want $500 to double, then the amount that we're going to be looking for is $1,000. So $500 doubled is $1,000. So sub in A equals 1,000. So now we're looking for 1,000. We still have 500 plus 30t, and we simply solve for t. Subtract 500 from both sides. Divide both sides by 30. We get t equals 16.66, and that carries on. So that's 16 2/3 of a year. Now we can convert that. That's a little easier to say. We're talking about years. 2/3 of a year is how many months? We're looking at 16 years and 8 months as the time it takes for this investment to double. C, what annual interest rate must be earned so that the investment doubles in 8 years? Well, at 6%, it's going to double in 16 2/3 years. We want to find out, we want to get a different account, one that's going to allow us to double our money in 8 years. Okay, so our amount is still 1,000. This time we know the principal still, it's 500. It's our original equation. And this time we actually know the t that we're aiming for is 8, but we do not know r. Okay, so we're using our same formula. We've got 1,000 as the amount that we're aiming for. 500 is our initial investment plus 30. Oh, except it's not 30 this time, 30t. It is 500 times r times 8. 8 years in there for t, okay? So let's start to simplify. We've got 500 plus 500 times 8 is 4,000 r. Subtract 500 from both sides. Divide both sides by 4,000. We end up with r equals 0.125. Now this is the rate expressed as a decimal. So what do we say? In order to double your investment in 8 years, we need to earn 12.5% simple interest. This reminds me of a pretty general calculation that investors often make assumptions based off of. So this is simple interest, but in the real world, everything is compound interest. And if you earn 10% per year, you will double your money in 7 years. So compound interest, you can already see, is way better than simple interest if you're earning, harsher if you're borrowing, of course. But the general investment assumption is at 10%, you double your money in about 7 years. It takes about 7 years to double your money at 10%. Either way you read it, write it, same thing. So this is just using the basic formulas that we have, subbing in what we know, finding out what we don't know. Example 3 is to analyze a simple interest scenario. You're given a graph. It shows the amount of an investment earning simple interest, and we're just analyzing what's there. A, what is the principal? Well, the principal is the amount of the initial investment. So this occurs on the graph where t equals 0. No time has passed, no money has been earned. So the amount that's in there is the principal. It's the vertical intercept. Therefore, $800. Judging by this graph, it's the vertical intercept. B, determine the annual interest rate. Okay, the annual interest rate, that's how much we're going to, it's reflected in how much we're going to earn per year. So it's going to be directly related to the slope of the line. Okay, so go ahead and determine the slope of the line. Let's say we'll determine the slope here, and I'll pick a couple points. We know we go through 0, 800, and I can see from the graph, and you can see from yours, that you go through 10, 1200. Okay, So the slope is the change in the amount over the change in time. Okay, this is really rise over run. This is the difference, A2 minus A1, A2 minus A1, over time, T2 minus T1. T2 is going to be 10, T1 is going to be 0. So here we go. We have, and I'll write those out. Here we go. We got A2 minus A1 over T2 minus T1. Simply rise over run. Y is over x's, which gives us 1200 minus 800 over 10 minus 1. Reducing, that's 400, sorry, 10 minus 0. X-intercept, y-intercept happens at x equals 0. 400 over 10 gives us a slope of 40. Well, that's not the interest earned, but it is the amount earned per year. So now let's look back at our formula for interest, which is I equals PRT. We've determined that this is the interest earned per year. So T is 1 when M is 40. The principal was 800, and we want to find out the rate. Okay, so if we're going up $40 per year, this is how you find out the rate that you needed to earn per year. Divide both sides by 800, you get R equals 0.05. Therefore, the annual interest rate is 5%. Okay, so we used our graph, we found the slope, which was rise over run, a run of 10, a rise of 400, slope of 40. Okay, so in 1 year it went up $40. That means out of the $800 simple interest, the rate had to be 5%. So every year you're going to get 5% of 800 back, which is $40. Okay, annual interest rate 5%. Last piece here, C, write an equation to relate the amount of an investment to time. Well, we know it's partial variation and we know it's linear. So you don't need to write this, but sometimes it's helpful just to, tried and true, y equals mx plus b. We don't have y and x, we have a, and we don't have x, we have t, and we still have slope and y-intercept. All right, plug in what we know. Amount equals 40t plus our y-intercept, our original amount of 800. And again, you see the exact same formula, style of formula that we looked at in the earlier examples. Okay, simple interest is a linear function. Your practice problems are from page 424, numbers 1 through 9. Enjoy.